Good. Welcome everyone. I'm Thomas from the iOS team here at GoodNotes, and this is one of our GoodNotes engineering brownbag sessions. In these sessions, we are sharing knowledge across our team, and we have decided to make them public so that everyone can see what we do and what we share among each other. If you like what you see in these sessions, feel free to look into our job opportunities by going into goodnotes.com/careers and apply for any of the open positions that we have there. Today we have Vincent from our DevOps team, which who will be talking about composable CI/CD pipelines using GitHub Actions and TypeScript. So without further ado, thank you, Vincent, for volunteering for this talk.
Okay, thanks. I will share my screen now. All right, can you see the screen? Yeah, okay. So thanks for the introduction. I'll go over some examples of how we could use GitHub Actions to write more composable CI/CD pipelines. First off, here's a random example of some workflow. And to be fair, I wrote that workflow. So it's based on a lot of bash that we used before, but basically translated into a GitHub action workflow. Wanted to highlight some problems here that I think if we adopt this way of converting our existing automation to GitHub Actions, for example, we may rely on GitHub Action internals. Originally, when you wanted to expose certain information, like if you're working with secrets, you would need to call a special command in GitHub Actions that would be interpreted by the GitHub Action runners to do a special thing like masking a password. And there were a few others in the past, such as set output and set environment, but they've both been deprecated. So once GitHub deprecates these internals, you have to go and update every shell script that uses those methods. So you're kind of tied to some internals of the way GitHub Action works if you use big monolithic shell scripts as GitHub Actions. It's easy to get started because Bash is very easy to start writing some code, calling individual commands like the set command we see here. But down the line, it becomes a bit harder to understand. If it had taken a while that you've touched this, you forget the plot. You don't remember, like, how do I test this? If I break something, I have to do many commits, invoke the workflow, and see the result. And of course, having programmed a script inside a YAML file is never something good. You lose a lot of the IntelliSense or automatic formatting or validation that you could do against shell scripts. So what do I mean when I say composable? Composable means that the workflow is itself composed of much smaller, testable, and reusable components. Why? This allows us to test these individual components and to refactor them and add features to them without worrying about breaking the usage of it, as long as we are defining unit tests, and I will go into details how we can define unit tests. Also, that gives us more confidence that the execution will be correct and our pipelines will be more expressive. In the end, if you use something like Datadog CI/CD, you could also get very detailed information about how long each step in your workflow takes, and you can start to focus on what you need to optimize. So here's the same example where I've kind of rewritten it a little bit using more actions. So it's not really fair because like the configure AWS credentials was below this huge block, but I think the most important component here is that instead of having to call subs decryption and storing the result then in the environment by evaluating the output, we are now calling a function called action_secrets to environment, which just takes a reference to the file, and then you can specify the specific environment names you want to expose, and you can also specify if these should be exposed as environment variables in the runner, or they should be just exposed as outputs from this action. So those are both features of GitHub Actions, that you can expose outputs of one action to be used in the next one. Okay, so currently, if you want to start using GitHub Actions in our, or what you need to do to use this, you would need to create a dedicated GitHub repository to maintain the action and test and version the action in separately, so it can be reused across our repositories within GoodNotes. So we need to, in this case, I've created action secrets environment that you saw earlier, another action to get CloudFormation outputs, and then there's also an action template that you can use to create more actions. Current template is forked from the TypeScript action, and once you fork it, there's an option that you need to enable to make it accessible from repositories within the organization. So the advantage of writing these actions in separate dedicated repositories is, like I said, that you are able to test things more carefully. So I wanted to dive right in, and maybe this is confusing if you've never seen just unit tests or worked with TypeScript, but here is a unit test to test that specific action I showed earlier, the SOPs action to decrypt. In this case, I am writing a test that if you provide a non-existing file, the action should throw an error that inside the message there's a regular expression that it must contain something saying around does not exist. So another test I'm doing here is to make sure that if you do not provide any keys to extract from the secrets, it also should again throw an error saying that something length is 0. Same if I want to, if I actually do specify keys, but the keys don't match with what's in the secret, I would also like to know as a user that maybe I made a mistake, I picked the wrong file. So if I'm picking up the fake environment variable, and then I should get a message saying that there's nothing matched. And finally, if I call everything successfully, the happy path, then the result after I decrypt using the fixture keys, I should get exactly the output of the fixture secrets. So this is an example of a unit test on a decrypt function that we can write if we are using a higher level programming language and we are exposing the functionality through a GitHub action. Another example is, for example, the CloudFormation GitHub action. It actually needs a bunch of AWS resources to exist. And that's annoying. If we are running unit tests, we don't want to connect to AWS services. So again, I can write my GitHub action and make sure that if I do a get stack outputs call, that I can mock the response. So I can create a mock response that the describe stack output call should return, which and then I can validate that if I call the action, so I have a function called get stack outputs with the name of the mock stack and for a certain key, then I should have expected to receive the command at least once or exactly once. And so if I have multiple outputs, it also gets called once. And then to have received the command with the parameter stack name mock stack, because that's what I pass in when I call the function. And then finally, I must get exactly the response to match the mock response. So in this case, I am validating that the result will be, sorry, distracted. I should mute my Slack. So then finally, I mentioned that when you write shell scripts like that, you are using internals such as, you know, the GitHub Actions. You have features like add mask, set output, set environment. 2 of those were deprecated. So GitHub actually exposes an SDK that gives you easy, sorry, I'm going to mute my Slack. All right, think. Okay, so if you are using the SDK for GitHub Actions, you have functions such as you can get input, you can export environment variables. So those are hiding away how GitHub Actions does this internally, and these SDKs are updated as GitHub deprecates some of those internals behind the scenes. So the GitHub Action, the SDK will actually detect what is the version of the runner and correctly use the right methodology. So you don't even need to worry about that if you write your actions this way. So what I want to know is, I want to make sure that my action actually gets the input correctly. So if I call my action with a bunch of environment names, I want to make sure that the action was called with exactly the entries of the secrets. So am I able to create spies? That's different from mocking. With spies, you can intercept the call and then look if the call has been made. So you can expect the call that export values has not been called if the export setting is not been set. So finally, when you write GitHub Actions using a higher level programming language, and we are using unit tests and these mocking and spying features, we're actually quite confident that our action will work the way it should. But from experience, when you are refactoring things, sometimes you may forget to update the entry point to your action, and then when even though all your unit tests and mock tests and everything works, turns out that your action actually doesn't work. So the real test is to actually, on your action repository, use the action locally to make sure that it works on the clean machine without building. So this is exactly how any consumer of the action will use the action. And this, of course, is a little bit harder if you need to do a call to AWS to talk to CloudFormation to get outputs. But in case of the sub-secrets decryption, I was able to provide an encrypted file locally and ensure that if my action runs, I'm calling the action here, and then I'm actually using a GitHub script to validate that all of the fixtures are met again. So this is another advantage of separating your GitHub Actions into dedicated repositories. You can, with just unit tests, you can make sure that your end-to-end tests only run if you are currently connected to a certain environment. Because I use AWS Vault to identify which environment I'm connected to, I am checking in the process in the environment if the AWS Vault session has been set. If it has not been set, it will skip the next text. If it has been set, it will use describe, which is the jest way of saying like you're going to execute this test. So as you can see in the on the left screen, when I run jest, it was skipped because the environment was not set, so the AWS call could not be made, so it skipped that test. But when I ran it the second time, I had made sure that I was connected to SSO GoodNotes staging environment, and it actually ran the additional test to call the action. This is actually a third, I don't know, maybe the sixth way of calling the action, which is using a node to call it. This is quite complicated to execute the action, and if there are errors, it's very hard to debug. So I don't like this this way of testing the action. But it's also a way to make sure, like if you cannot run it in the GitHub Action workflow, you can make sure that if you run it under certain environment setup, it will also run the AWS test. Of course, it depends then on this CloudFormation stack, which is a little bit stupid. Like your test should not depend on these external resources. Okay, so finally, this is, I think, more of an advantage of just being on GitHub and using Dependabot. If you are dedicating your action into its own repository, you can automatically get the dependencies bumped and create new versions with nice release logs. That's kind of an advantage of being outside of a monorepo, that you're able to version specifically only this part. And this is another nice to have, which I copied from another action. It's also able to auto-generate your documentation. This is actually quite a complicated way of generating documentation. It's much easier if you use GSDoc. And finally, I know this is all very detailed. To be honest, these slides are more meant to be for internally as a guideline. If we want to start writing actions, how should we test them? What types of testing can we do? So here's another example of if I'm writing a GitHub action and I am directly calling JavaScript instead of using bash. So there's two options. We can use the node. We can set up node on the workflow environment, and then we can install the OctoKit action and then just run the OctoKit action with our script. But we could also just use the GitHub actions like script action/GitHub script, which we are already using. It basically gives you the ability to easily write a step within your workflow to interact with your pull request. For example, in this case, it automatically creates a ticket. That's all from the example. If I share the slides, you can click on the link and you will be able to see these examples. So here's an example of the first random script where we were sourcing environment variables. What I like to highlight here is the difference between using bash. To me personally, I find the left side a bit confusing. I'm trying to source a certain environment file by sourcing the environment file and then reading through the, wait, I have to read this again. Right. Okay, so the first step sources the environment file into the bash shell, and the final step, which is prefixed by a lot of comments because it's a little bit confusing, it's a set command that basically reads that environment file again, substitute any variables that exist inside the environment file, but makes sure that it drops any lines that start with a hashtag or any empty lines, and it only captures the right-hand side from each line and then substitute the rest of it with the actual environment variable. So this particular snippet of bash is quite confusing. I would argue that the snippet on the right, the JavaScript version, is a little bit less confusing, although if you never see JavaScript, it might actually not look that much better. So in this case, I am using the GitHub script action from earlier. I'm using Node.js features to read the file from the disk, and I am executing the command, the source command, and then I am exposing the environment that is created by this command. So basically, I'm calling bash to source the environment file, and then I'm getting the resulting environment, grabbing down to only the variable names that I want to read. And finally, I'm using the SDK to set it to fail if something errored out, or to actually export the variables. So I am not bound to internal GitHub action things such as you need to send the output to the GitHub env environment variable to expose the environment. I'm actually calling the core.export variables feature. So to me, it's a little bit more clear because on the left side, I'm interpreting the file twice. On the right side, I'm sourcing it once, reading the variable names by reading the keys out of the environment file, and then I'm exporting it. I don't know. I think the right one is has less room for error. I can tell you this set expression is quite complicated, and it's easier, and it's hard to get right, and it's easier to make a mistake. Like initially, the first iteration I wrote had a bug because the environment files had some expressions like Python shell scripts inside them, so I had to actually source it twice. So it was I think the right one is better. So if we do things like that, having this whole JavaScript snippet inside YAML doesn't improve anything on compared to having a bash script inside YAML, right? So there is the way, and this is another example. there is a way to actually create a bunch of functions out, inside a JavaScript file and then refer to that JavaScript file by importing it and then calling the functions inside that JavaScript file. And this would be the best of both worlds. You could, of course, move that snippet into its own repository and version it so it can be reused across different repositories. But if you don't want to do that, if you just need to have this JavaScript locally, then you can do it like this. So that's the status of where we are at in terms of like using GitHub, writing GitHub Actions inside our organization. And I wanted to highlight that there are a couple of things that I would still like to do, which is use conventional commits to automatically generate the release notes. Currently, the release notes are actually auto-generated by the GitHub CLI tool. It's already doing a pretty nice job, but conventional commits allow you to version your GitHub action properly as well. So to make sure that you are bumping major or minor version in a way that it's clear to anyone consuming your action that you are not breaking the contract. And then finally, there's actually a very nice GitHub action to create GitHub actions. It's Jason Atko's build and tag action. This action does not require you to commit your compiled TypeScript into your GitHub action. So the problem here is that if you want to write a GitHub action, it has to be JavaScript. So you can use TypeScript to write the GitHub action. I mean, the output has to be JavaScript. You can use TypeScript to write the GitHub action, but you must have the JavaScript inside your repository or your package, because that's what GitHub action runners execute. So GitHub action runners do not understand TypeScript, and they don't have the TS node component to run TypeScript directly. So if you're writing GitHub actions that are to be used out of the box, you must, part of your release process, include the compiled JavaScript, and you can ES build it or Webpack it or whatever. You can create a nice, concise distribution of your TypeScript. But the default TypeScript template from GitHub actually commits the dist and validates that each time you make a change in TypeScript, you have also updated your dist folder. So if you make a change and you don't update your dist folder, the pull request will fail. There is a nicer way, which is this build and tag action, which only compiles TypeScript to JavaScript when you tag your release. Then it will create a separate commit with your TypeScript compiled as JavaScript. So that is a tagged commit that is loaded by the GitHub Action Runner. So your JavaScript dist folder is never inside your main branch or your master branch, which is nicer from a developer's perspective. I think the rest, yes. So a couple of gotchas. So TypeScript learning curve can be difficult. If like myself, I've never worked with JavaScript until maybe the last 6 or 8 months. And I had to learn a lot about the fact that the way classes are implemented in JavaScript is tricky. For example, a lot of the original JavaScript modules, when they expose a class, when you use a constructor and you pass in an object of the same type, they just pass back the original object instead of creating a clone of it. So I've got some really funny bugs, and that is very hard to find, because if you look at TypeScript, everything works correctly, but once it runs, it's very hard to understand that actually this particular JavaScript module construct or class constructor just returns the original object if you pass in an already existing object. So any changes you make actually affect both the original and your new instance, which is one thing that really took me almost a day to figure out. So the TypeScript and the JavaScript learning curve is quite hard. I think JavaScript in general is a big ecosystem. So luckily, I think with GitHub Actions, the template repository puts in place a lot of like conventions for you. It tells you, look, this is how you should get started. And if you start by looking at existing bash or actions that you have, and you try to just use the TypeScript starter repository, you will be guided to create it in the right way. Yeah. Okay. So And the final one I already highlighted, which is if the integration workflow isn't running the action itself in a clean runner, it's still easy to break things. Yeah, that's it. I don't have any more slides. I don't know how I did on time. Yeah, so questions, I guess.
Vincent, I think it was fantastic on time. And yeah, let's open it for questions from the audience. I have one to get the conversation started. So what is the granularity that you suggest to extract behavior into actions?
Okay, so I think the way I look at it is when I look at an existing action or shell script and I see some repeated things, for example, SOPs decryption or the getting CloudFormation outputs, that's something that was happening in a lot of different places. And I thought that it would benefit a lot from abstracting that into its own functionality. I think it's kind of like when you're refactoring a shell script and you see repeated copy paste scripts that maybe you would refactor out in a function. I think similarly, you could consider using an action. There are, yeah, it just means that GitHub Action Runner will need to go and fetch all of these actions at the start of the run, but it does that very quickly. I haven't seen any performance issues there. So I would say it's really up to like case by case and depending on what you're working at, what kind of, if you're refactoring, if you're starting out from scratch, that's a bit harder. Maybe if you have a great idea of like these are the big steps that I want to do, and this looks like something that could be an individual component, then I could write an action for that. Yeah.
Mm-hmm. And I guess we can self-host these actions in case they are kind of private and we cannot expose them to the general GitHub marketplace of actions, right?
Right. So at the start, I said that currently in our GoodNotes organization, I've created a template that a private template that you can fork. So I mean that you can use to create your action as a private action, and then you need to make sure to flag it like this repository is something that can be used as an action within workflows. So then GitHub will allow other runners within the organization to get to that action. So you no longer have to make the action public. It used to be that you had to make the action public, but at the moment you can have fully private actions. Yeah.
Yeah, that's great. Any other questions?
One stupid question. Where does the test for the GitHub action runs? It runs in another action.
Oh yeah, so no, this is all part of, like, maybe I should share my screen and show you the actual repository. So if I go, sorry, there's a lot of slides. Maybe I should go here. If I go, oops. Let's look at an actual action, right? Oh. So in this case, I'm looking at the action that is used to decrypt SOPs files and then expose them as runner environment or as outputs. And when I'm working on this action, I have tests here, and they are being run as part of the, like, when I do a pull request to add a feature, then on pull request it will run all. So this will build, sorry, run all will compile into the test itself is actually using jest, right? No, the run all is running jest, sorry, is running jest and compiling, and this is a separate test. Make sure that it's running on a clean machine as well. So yeah, these tests are the jest tests. So they are running as part of the refactoring or maintenance of the action. So we are using the action somewhere else, but we want to make sure that we don't break the contract. So whenever I add a new feature, I want to make sure that everything, like it should still mask the outputs. It should still export the secrets if you set the runner and to true and things like that. Does that answer your question?
Yes. Thank you.
Great. So if there are no more questions, I think we can end it here. So thank you, Vincent, for the talk, and
Thanks
see
all.
you on the next one.
Yep. All right. Bye.